Compressible Flow tutorial number 23. A pitted probe is inserted in an airflow in a pipe in which P1 equal 800 kPa absolute, T1 equal 40 degrees Celsius, and M1 equal 3.0. What pressure does it measure? So this question can be reflected to this diagram. We have a pitted probe here, and then the flow is mark number 3.0, and then here the pitted probe shows 800 kPa absolute. Then we have a pitted tube like this, and when the flow at this area, it creates a shock. Then the value here need to be calculated. So from this situation, we need to understand that we could divide into three conditions. Condition 1 here is when the flow at 3.0 Mach number and the pressure is 800 kPa. Then it creates shock, and then we need to calculate what happened after the shock here, and this is condition number 2 here. And then as we learned in Fluid Mechanics 1 and Fluid Mechanics 2, if we have pitted tube like this, the flow will flow inside this tube and then it will stop. Means that the flow will change itself into stagnation condition. So means we need to label stagnation condition as is condition number 3. So means the flow will become like this. It has situation before the shock wave, then the shock wave occur here, and then the flow still flow at point number 2 here, and then the flow will stop and create stagnation condition. We could calculate Mach number 2, M2 here by using this equation, because it is before and after the shock wave. We need to use the normal shock wave equation of Mach number. We substitute all the value. The K is 1.4, M1 is 3.0. We could get that Mach number M2 square is 0.225. Then we could say that M2 is equal to 0.4752. Then we could calculate the pressure after the shock wave by using this equation, the equation for normal shock wave. The pressure ratio before and after shock wave, P2 over P1 is equal to 10.33. Then we could calculate pressure after the shock wave, P2 here, by multiplying 10.33 and 800 here. And we could say that the pressure after the shock wave is 8,266 kPa absolute. Then we need to calculate the stagnation pressure, because point number 2 and point number 3, both condition here, both situation is after the shock wave, so means the flow is isentropic flow. We could calculate the ratio between P3 and P2 by using the isentropic flow like this. We substitute all the value. M3 will become stagnation condition, means the value of M3 here is equal to 0. The value of M2 is 0.4752. We solve this equation, we could get that P0, pressure at stagnation point, is equal to 9,648.75 kPa absolute.